This example is about reverse engineering. We have the finished part here. This is the finished solid using reverse engineering. If I hide that and show the faceted data, this is what we were given. And the task was to reverse engineer this into a BREP solid. So if I go through the steps, we'll go into the first step. And the first thing we would do is start extracting data. So we would extract these faces one at a time. And continue extracting. Now the goal here is to do the top side. So we want to get the top, and then we'll do the middle, and then we'll do the bottom, then we'll combine them into one solid. So we have all the extracted surfaces for the top part of the model. We do some extrusions and some modeling in that to get the sides, but the next thing we would do would be a combine. So we combine these surfaces together, and when you prior to the combine, we would extend them, and then we would combine them, and then maybe some finishing touches. And then what we would do is extract the finished part, being the top, and there it is. There's the finished part. So we have the top. So we would repeat those steps for the rest of the model, for the middle portion, extracting, enlarging, and combining the surfaces. And then we would do the bottom. And then we have the three different sections, all using the same steps, the same methodology, and then we would finish it by combining the shapes together. And that last combine gives us a finished solid model. Then what we would do is we would compare it to the faceted data. So we could use our analysis tools under analysis, and we have a few created already. So the first one we would do would be a deviation gauge, and we could do a deviation to the surfaces created to the faceted data. So here's our deviation gauge, and it tells us how far the surface deviates. So if we need to go back and modify and improve the surface, we can. And then the modification, it will update. And we could take other measurements by just coming in, and we could pick certain areas and see how far it's off in different areas, go back, modify, and improve our surface and make it better. So that would be deviation gauge. Another thing we could do is we could do a section analysis. So if we turn off our facet body and we shade our data, you can see the quality of our surface. So the section analysis is right here under analysis. And we could kind of come through, we could see these curvature combs and make sure that they are smooth going through. And where the radius comes in, you can see it's G1 continuity. So it's a good surface. Another nice check is reflection. So if we select the surfaces, we can see the reflection on the surfaces. And mostly you want the big broad surfaces to see the reflection. But this reflection is important because that's the flow of the surface. If you see zigzags on there, you know that you have issues with your surface. And if this is product data that you're going to sell, if you see reflection issues here, your customer will see them also. And we can change the reflection, different types of reflections to get different images. And we can go into even scenes, and we could do reflections from objects to get an idea of your surface quality and add some light and color. But it's a good idea to inspect your surface using these tools to make sure that you do indeed have a good surface, and then you can right click and go right back to shading and you're back to shaded mode. Or you could right click and go to face analysis, and you have your analysis mode back on.